Fellow soil scientists, I have the privilege and honor to talk to you for the month of August viewpoint, and I chose the topic of Did the Stone Age end because the world ran out of stones? Similar to the stone, Bronze and Hydric ages, the era since circa 1750 is known as the carbon civilization. With a continuous increase in human population and the ever-growing economic affluence, the global energy demand has increased from 299 exajoule in 1980 to 575 exajoule in 2015 at an average rate of 8.8 exajoule per year. The energy consumption is projected to increase to 627 exajoule by 2020, 700 exajoule by 2030, and 776 exajoule by 2040. The annual rate of increase in energy consumption between 2015 and 2040 is estimated at 6.8 exajoule per year. In 2012, with 553 exajoule of global energy consumption, 80% was supplied through fossil fuel consumption. Only 11.3% through biofuels, mostly wood, 5.5% through nuclear, 2.2% through hydro, and 0.4% through other sources. In 2015, with 607 exajoule of energy consumption, 86% was supplied through fossil fuel consumption of coal, oil, and gas. In comparison with total energy consumption, the direct agricultural use of energy has also increased steadily and is expected to increase even at a higher rate in the future. Direct energy used in agriculture comes from diesel consumption, use of agricultural chemicals, irrigation, heating, cooling, and grain drying. On average, in the US corn belt, producing 1 bushel of corn grains, that's about 25.4 kilograms, requires 0.5 gallon of diesel, that's 68.9 megajoule, and by 2040 the global energy demand will increase by 30% compared with that of 2017, which is equivalent to adding another China and India into today's consumption. Despite the high environmental footprint, fossil fuel will remain to be among major sources of energy until 2015 and will thus continue to exacerbate the anthropogenic climate change. The cumulative carbon emission between 1715 and 2015 is estimated at 600 petagram, of which 410 petagram was from fossil fuel combustion and 190 petagram from the land use change. Total emission from land use change since the beginning of agriculture to the onset of industrial revolution may be as much as 320 petagram. Of the total anthropogenic emission, that's 600 petagram since 1750, 260 petagram remained in the atmosphere. Furthermore, global reserves of fossil fuel are estimated at 4,130 petagram, comprising of 350 petagram of coal, 230 as oil, 140 as gas, and 250 as others, such as shale. Thus, carbon addiction of the humanity with consumption of 10 petagram of carbon per year at present is not likely to be restrained by depletion of the world's fossil fuel reserves in near the future. Just as the Stone Age did not end because the world ran out of stones, similarly it's hoped that the carbon civilization must also end long before the world runs out of fossil fuel. All soil and environmental problems of the 21st century are directly or indirectly related to humanity's addiction to fossil fuel. Therefore, decoupling the humanity's well-being from fossil fuel carbon and identifying no carbon fuel sources is a high priority. Humanity needs a fuel source that is safe, secure, healthy, renewable, economic, and environment friendly. This is the right time to transition to no carbon energy, not because the world is running out of fossil fuel, but because of its high environmental footprint. As Carl Sagan said, anything else you are interested in is not going to happen if you can't breathe the air and drink the water. Don't sit this one out, do something.